Hi, welcome back to Chapter 2, Atomic Structure. Today we're still in Chapter 2.1, Bohr's Atomic Model, which we will focus on calculation. These are the formula that you supposedly remember. First, second, third, and fourth formula. Don't forget, last video we learned one formula. Energy at certain energy level En equal to negative RH 1 over n square, at where the RH reward constant is same to 2.18 exponent negative 18 joule. Okay, before we continue, one more thing just want to remind all of you. Okay, all this formula is referred to one electron only. Okay, so all the wavelength or all the frequency and also the energy that you calculate based on this formula is referring to one electron only. This exercise is taken from your lecture notes. Calculate the wavelength in nanometer, frequency, energy that associated with the second line in the Balmer series. When we can see the word line, you will have the idea that the electron is dropped from higher energy level to lower energy level. So when you can see the terms Balmer, so we know that finally the electron is dropped to n equal to 2. So what is the initial energy level of the electron? So second line is referred to 2. Okay, so final energy level for the electron is at n equal to 2. So I will plus 2, which is equal to 4. Which means that the electron is dropped from n equal to 4 to n equal to 2. Next, then we list out all the formula, the 5 formula here, 1, 2, 3, 4, and 5. Okay, so the first one, they ask us to determine the wavelength. So we look at this formula here. Among these 5 formula, the 5th formula is the one that that contain wavelength. So means that I will have the idea that we need to use 1 over lambda. Okay, then now this is lambda is the wavelength which we didn't know the value. RH according to here is 1.097 exponent 7 per meter. Okay, so alert, we have two Liebig constant. One is in the unit of joule and then another one is in the unit of per meter. Because this is the wavelength, so we have to choose the one with the unit per meter, and then N1 always less than N2. So in this case, the N1 is 2 while the N2 is 4. So just substitute the value in and then do the conversion. Now let's proceed to the question B. Calculate the frequency. Again, we list down all the formula. Okay, so we have 5 formula. The formula that involve frequency is third formula and the fourth formula. Okay, so the symbol for frequency is like a VE sign, which we can read it as mu. So when we have this formula, but we cannot use the third formula because from the question here, we still have no idea what is the change of the energy. Okay, but then we can use the fourth formula. So let's check. Yes, we can use the fourth formula. So another symbol for frequency is F, or you can use the mu. Okay, so frequency is the one that we are going to determine. So this is an unknown. C is speed of light, which is a constant. And then wavelength is the one that you determine in the question A. But remember, just now we determined the wavelength is in the nanometer. Okay, but then the speed of light is in the unit of meter. So before you convert, before you do the calculation, we have to convert the nanometer into meter. So just press the calculator and then end up you will get the answer is 6.13 exponent 14, and then the unit here is per second, or we can write it in hertz. Question C. Calculate the energy that associate with the second line in the Balmer series. So again, the energy here, because it is involved two energy level from n equal to 2 to n equal, from n equal to 4 to n equal to 2. So means that basically the energy here is referring to change of energy. So this triangle is mean change of energy, So E is energy, so this is means change of energy. So again, we can look at the formula. So basically from here we can see there is formula, second formula, and the third formula is able to help us to get the energy. Okay, so in this example, the formula that used is the second formula. So n initial square minus n final square. So in this case, again, just reminder, the n initial is n equal to 4, while n final is n equal to 2, because light produced when electron drop. So just substitute in the value, okay, then you will get the answer 4.09 exponent negative 19, and then the unit is joule. How about if I use the third formula, I also can get the answer. So either you substitute the wavelength into the formula delta E, or you can substitute the frequency in. No matter what are the formula that you use, I think the final answer is almost the same. They maybe have the difference in these decimal places only. Okay, this exercise also from your lecture notes. This one we call it as line spectrum, and then line A will consider as first line. Okay, so how we determine A is first line but not E is the first line? Okay, normally we find the gap here. Okay, the biggest the gap, so means that it is first line. Okay, Paschen series means that finally the electron will drop to n equal to 3. So let's say what the question asks for. Give the transition. Okay, so transition here is means the movement of the electron for E. So just now say A is the first line, B is the second line, C third line, D fourth line, and E is the fifth line. Okay, so fifth line in Paschen series. So Paschen, so n final equal to 3. So fifth line means that the initial is 5 plus 3, so it's equal to 8. So for the first question is the electron will drop from n equal to 8 to n equal to 3. Tutorial question number 4. Calculate the wavelength with the symbol lambda and also the frequency. So from these 5 formula, if I want to determine the wavelength, basically we will use 5th formula. And when we want to determine the frequency, we can use the 4th formula, because the wavelength later can be substituted into the 4th formula, then we can identify the frequency. Okay, the next one we will check here, 4th line in Lyman series. So when it mentioned about Lyman, we know n final is equal to 1. So how we determine the n initial for the 4th line? So 4th is 4, Lyman is 1. So 4 plus 1 equal to 5. So for the fourth line in Balmer series, then we will have the idea that the electron is dropped from n equal to 5 to n equal to 1. Okay, another question. Third line in Paschen series. When mentioned about Paschen, we know that the n final equal to 3. While third line, n initial equal to 3 plus 3, so equal to 6. So for the third line in Paschen series means that the electron is dropped from n6 to n3. Okay, but because of just now we mentioned that we have to use fifth formula to determine the wavelength. But here the formula for this, we are not using n initial and n final, but we use n1 and n2. So this is the reminder, n1 always less than n2. So in this case, final is n1, while initial is n2. So after you get the wavelength, then you can substitute the value of the wavelength into the fourth formula, and then you can identify the frequency. Okay, so you can check the answer over here. Question number 4. An electron of an hydrogen atom undergo transition to form a line in Balmer series with a wavelength 486.2 nanometer. So question A, state the region. So when the question asks about the region, we have 3 possible answers: ultraviolet, visible, or infrared. Okay, so at Balmer series it means the electron will drop to n equal to 2, which it is referred to visible region. Number B, determine the energy level. So energy level is represent n of the excited state for this transition, because wavelength is given and then involve energy level. Again, based on the 5 formula that in this chapter, we are going to use the 5th formula here. Okay, because wavelength is given, and then this one is given one of the n, and then this n is referred to n1. Okay, because finally the electron drop to form Balmer series. So n1 is 2. So RH, Ribot constant, is given. So means that n2 here, the n2 is represent a excited state. So one formula with one unknown, so we can substitute all the value that we have into the formula. Just a reminder, because here given is in nanometer, but the Ribot constant, the unit for the Ribot constant is in meter. So you have to convert the nanometer into the meter by multiply by 10 to the power of -9. Okay, so determine the energy level. So after you press the calculator, you will get n2 equal to 4. Okay, but let's say the question have a bit changes. They ask you state the transition of electron which produce 486.2 nanometer in Balmer series. If this is the question asking, then you have to mention the electron is transit from n equal to 4 to n equal to 2. Okay, this is the answer for this question, while n equal to 4 is the answer for energy level of the excited state. Let's continue with question number 5. Okay, the light was emitted and then the wavelength is 525.56 nanometer. Calculate the energy of a photon and also 1 mole of photons. Okay, so what is the meaning of photon? Photon is the electron that carry light energy. Okay, so again, when need to involve calculation, we try to think of choose the formula from these five. So in this question, you will notice that second formula and third formula involve delta E, change of energy. So again, when the wavelength is given, means that it produce light. If produce light, means that the electron is dropped. So if the electron is dropped, it will involve two energy level. So if involve two energy level, then we are going to find the change of energy. Okay, this is why we choose either in between second formula or the third formula. Then we look at second formula. We need to know the energy level. From the question here, there is no any information regarding to the energy level. So that's why we are going to combining third formula with the fourth formula here. Okay, before we combine, again, just reminder, all the formula from 1 to 5 here, they are actually always refer to one electron only. Yeah. Okay, so when I combining the third formula and the fourth formula, I will get delta E equal to hc over lambda. So h is the constant, c also constant, speed of light, and then the 525.6 nanometer will going to substitute in here. Because of the unit of the speed of light is in meter, so I need to convert nanometer into the meter. So press the calculator, we will get the final answer is 3.78 exponent negative 19 joule, or you can convert them in kilojoule. So again, just now say that all the formula here is used to determine one electron only. Okay, so this is the energy released when there is one electron drop. Okay, so but another part of the question is asked us to determine one mole of photons. Okay, one mole of photon consists of 6.02 exponent 23. So that's why we multiply by 6.02 exponent 23. So and then it will be either in the unit of joule per mole, or we can kilojoule per mole. Okay, between joule per mole, we will more prefer in the kilojoule per mole. Okay, because later we will learn about one definition, and then it will mention that we need to always keep in kilojoule per mole. Okay, question number 6. Figure 1 shows the emission spectrum of hydrogen atom in Paschen series. Once look at Paschen, we have the idea that N final equal to 3. A state the region. So region for Paschen series is infrared. Please don't use short form in your answer. Yeah. Okay, and then question B, we need to show the transition for line PQR in energy level. So we hold this question first. Then next we continue with C. Calculate the energy of the light that produce line Q. Okay, so again, want to calculate, we have to choose the formula. Okay, before we choose the formula, then we need to know what is the information that we have regarding to line Q. Okay, based on this spectrometer, we can know that Q belongs to which line. Okay, we need to identify. Okay, then previous question we have mentioned that the largest gap will be considered as first line. So means that P is the first line while Q is the second line. Okay, so second line of the Paschen series means that the electron is dropped from, so we will use 2 plus 3, so means that the initial is dropped from n equal to 5 to n equal to 3. So here means again we have the energy level. And then we need to find the energy. So means that we are going to use the formula 2 lah. We need to find energy, delta E, and then we have initial energy level and final energy level. At the same time, don't forget, we have to choose the Ribet constant with the unit of joule. Okay, so this is the formula. We substitute in, and then this is the final answer. At where you will notice there is a negative sign. So then we know that our answer is correct, because from here we know that this is the line produced. So if line produced means that electron is dropped. So if electron is dropped means that it will release energy. This is why you will get negative sign when you do the calculation. Okay, now we are going to answer question number B. Draw an energy level diagram, and then we need to show the transition for the formation of P, Q, and R. Okay, so just now we already know this is the second line, and then it's from N5 to N3. So means that P, it shows that from N equal to 4 to N equal to 3. While R is the third line, so it will be from N equal to 6 to N equal to 3. Okay, before we label the transition, first we have to draw the energy level diagram first. Okay, so for the energy level diagram, have to alert label energy, and then for the vertical line, for the horizontal line, we have to label the energy level n equal to 1 up to n equal to infinity. Yes, n equal to infinity. Okay, so means that here suppose they have one more line, and then which is a bowl. Okay, and then try to be the gap getting. Another thing that you have to alert is you have to make sure the gap here is getting smaller and smaller. Okay, gap getting closer and closer. Okay, then only we will put the arrow to show that the arrow have to arrow down to show that the electron is dropped. So drop to where? Drop to n equal to 3 lah. So just now we say P is the first line, so means that drop from 4 to 3. So 4 to 3, 5 to 3, and then energy level equal to 6 to energy level equal to 3. Okay, so this is done for question B. Then don't forget we still have a D. Arrange the line PQR increasing order of wavelength. So we can use the energy level diagram as our reference here. Okay, the relationship of delta E here. So if we look at here, PQR, the delta E, the change of the energy of R is the largest or is the highest. How we know? Because the vertical line here is represent the energy, and then you look at here, the gap here, for the R and the gap for the P, so we know the change of energy for R is the highest. Okay, then we use this formula. The highest the energy, the lowest the shorter the lambda. Okay, so means that the R has the shortest wavelength, and the question is asked us to arrange in order of increasing order. So that's why the arrangement is R, Q, and P. Okay, let's continue with question number 7. The diagram show is a energy level diagram. This is not the line spectrum, yeah? Okay, next, the energy given here is refer to the energy at certain energy level. And in this case, they didn't show us the energy level. But you must know that the symbol of ABC are refer to the energy level. So if you want to know that what is the energy level for A, so you can use the first formula to determine it, because from here we are given the energy, and then the Ribot constant is a constant value. So now only left one unknown. So just substitute in the energy into the first formula, then you will able to determine the energy level for each of these symbol A, B, C, D, and E if you want to know. Okay, but for this question, I think we no need to do so. Let's look at the question. Question number A, determine the energy needed when an electron is excited from A to E. So excited means that the electron is jumped to lower energy level to higher energy level. So in this case, basically we know energy is absorbed. Okay, so later you will find out your delta E. Okay, because this one we want to find the energy needed, means that we are going to using the formula delta E. So we have two formula delta E in this case, but we no need to use these two formula, because from the question we are not given the energy level, we also didn't given the frequency or even the wavelength, because we already directly given the energy, so we can find the difference between these two energy. Okay, so if we want to find the change of energy, always we will use final minus initial. So final E is negative 6.06 exponent negative 20 minus the energy for A negative 545 exponent negative 19. So as just now we mentioned, because this one is absorbed energy, so when you press the calculator, you get the positive sign. Don't forget the positive sign here. Okay, continue with question B. Again, question B is about calculation. So we list down all the formula first. Next, let's look at the question. Calculate the wavelength of the photon when an electron drops from D to B. So drop from D to B, so the arrow is pointed down. So we will know this change of energy will be in negative value. Okay, so again, in this question, we no need to use the second formula, because we cannot know what is the exact energy level for D and B. So you may think that we can use the third formula. Okay, but if we have third formula, supposedly given us the frequency. Again, in this question, they didn't give us the frequency, so means that we will use the method that we use to answer in question A, at where we use delta E equal to E final minus E initial. Then you will notice that the final answer is negative value. Okay, then we will use third formula and combine with fourth formula. So frequency is not given, and then we need to find the wavelength. So we substitute the formula 4 into formula 3 and then rearrange. So we will get wavelength equal to Hc over delta E. Okay, in this case, when we substitute the value here, please alert, we no need to substitute in the negative sign, because what we substitute here, what we are going to determine here is the wavelength. Wavelength means it's like a panjang gelombang. So panjang tu cannot be in negative sign, That's why we no need to put the negative sign in. So again, just remind here, the negative sign here just want to show to us that the energy is released. It is not related with any calculation operation. So press the calculator, then you will please alert that if you didn't change the unit, because the speed of light is in the unit of meter per second, so the unit here also meter. If the question have specific, calculate the wavelength of photon in nanometer, okay, then you need to convert to nanometer. Continue with question C. Which electron transition in the diagram show us the longest wavelength? So again, in this diagram, you are given the energy. So means that from here we can determine the delta E. Okay, and then the question is asked us about the wavelength. Okay, so we have the idea delta E is equal to H mu, and mu is equal to C over lambda. So I can substitute the fourth formula into the so-called the third formula that we always use in this whole video, Hc over lambda. Okay, so now they ask us what is the longest wavelength. So longest wavelength at here means if I want longest wavelength, so the delta E have to be smallest. So from A until E, the change of energy will be at here, because previously we already know the gap between A and B, between two lines, will getting smaller and smaller. So the delta E in between D and E will be the smallest, which will cause the longest wavelength. So you have to mention the electron drop from E to D. Okay, we have to use the word drop. We can, okay, then it's correct. Okay, then maybe some of you will ask, can I say a jump from D to E? Cannot. Okay, because if you D to E means that electron is jump. So electron if is jump, they are going to absorb energy. So if absorb energy means that you cannot see any photon. So if there is no photon, means that there will be no wavelength. Okay, so must be electron drop. Okay, next one. The highest frequency. So here, frequency is getting higher, delta E also getting higher. So again, this one is related with the dropping, electron drop. So for this time, the answer will be the electron drop from E to A. Drop from E to A. Okay, figure 1 actually is the line spectrum. Okay, then read the question. Part A, they ask us to calculate the ionization energy in kilojoule per mole. Okay, while part B, they ask us to name two species that exhibit similar line spectrum as that of hydrogen atom. Okay, so before we can do the calculation, we need to know what is the meaning of ionization energy. So ionization energy, basically, this one I already simplified. It means the energy required to remove one mole of electron. Okay, so keyword at here is one mole of electron. That is why the unit here is kilojoule per mole. Okay, so if you want to remove electron, which electron that we will be removed? Most of the time, we are going to remove the electron which is the furthest from the nucleus. Why we remove the one furthest from the nucleus? Because the attraction towards the nucleus is the weakest. So means that it's the easiest for the electron to be removed. Okay, so and then if you still remember, if according to this line spectrum, the largest gap here, the first line will consider it will be considered as first line. Okay, and since we want to remove the electron, so we are going to remove the electron from the furthest. So this one will be considered the smallest gap will be means that the electron is dropped from the furthest energy level. Okay, so means that later when we do calculation, we are going to use 91.2 nanometer. Okay. Okay, so again, once we want to do calculation, list down all the formula. So in this case, because from the figure 1 just now, you are given the wavelength. So means that we are going to use fourth formula, substitute into the third formula, and then we are going to use delta E equal to Hc over lambda. Okay, so after we get the calculator, this is the change of the energy that required to remove the electron. But again, all this formula here actually is refer to one electron. But if you still remember just now, the question is asking us to look for the ionization energy. Okay, and where if you still remember just now I say ionization energy means that you are going to remove one mole of electron. Okay, one mole of electron is different from one electron. Okay, so if we want to look for one mole of electron, then we have to multiply with the Avogadro constant. Okay, so after we multiply with the Avogadro constant, and then you can try to keep it in in the unit of kilojoule per mole. So which will be 1312 kilojoule per mole. Okay, reminder again, one electron is not equal to one mole of electron. Okay, because one mole of electron is equal to 6.02 exponent 23 electron. Okay, this is why one electron is different from one mole of electron. Okay, this is the last question, question number 9. State the dual nature of electron using the de Broglie postulate and also the Hinsberg uncertainty principle. Okay, so we look at the dual nature of electron first. Okay, de Broglie postulate state that particles such as electron possess dual nature. So the meaning of dual here represent two. So what are the two? Means that they are the particles, and then also they are going to show the wave properties. Okay, but when we refer to the Bohr's atomic structure, Bohr's atomic model, they only emphasize that electron is a particle. Okay, is particle, but they didn't prove that electron have the showing the wave properties. Okay, so this is considered the weakness for the Bohr's atomic model, because de Broglie able to say that electron is particles and also can show the wave properties. Okay, second, Hinsberg uncertainty principle. Explain that it is impossible for us to measure the position and also the momentum of the particles. So the particle here is referring to the electron. Okay, this is due to the size of the electron is very small. So it is very difficult for us to know where is exactly the position and also the momentum of the electron. And also electron always moving. Okay, but again, according to the Bohr's atomic model, they has mentioned that the electron is always circulate the orbit. Okay, but then it sounds like that we can identify the position like at n equal to 1, n equal to 2, or at n equal to 3. Okay, but in the according to Hansberg mentioned that we are impossible to measure the position and the momentum of the electron. Okay, so give So continue with B. Give one Bohr's postulate that is contradictory to the above postulate. So it's the first one, okay? Because from here we say that electron is secured the nucleus in a well-defined path called an orbit. Means that the first postulate lah. Okay, this is another words when you want to write in. Okay, means that the first postulate that stated by Bohr is contradict with the de Broglie and also the Heisenberg uncertainty principle. Okay, that's all for chapter 2.1. So we'll see you again in chapter 2.2.